Why the t becomes normal. Why does estimating spread make the t-curve heavier in the tails? Student t-normal convergence shows how the standardized t reference loses its extra tail weight as degrees of freedom increase. A t distribution is symmetric and centered at 0 like the standard normal. But finite degrees of freedom account for uncertainty from estimating a standard deviation. The visualizer helps explain why small sample mean procedures use t, and why the normal approximation becomes close as that estimation uncertainty diminishes. A t variable is z divided by the square root of v. Divided by nu, where z is standard normal, v is independent chi-square. With nu degrees of freedom, and nu is the degrees of freedom. As nu grows, v divided by nu concentrates near 1. So the random denominator approaches 1 and t approaches z. For df greater than 2, t variance is nu divided by nu minus 2, which approaches 1. For very small df, some moments do not exist, illustrating how heavy the tails can be even though the curve is symmetric. Convergence in distribution does not make finite t and z probabilities identical. The difference is intentionally conservative in a t procedure because the standard error is estimated rather than known. Compare two-sided 5% reference cutoffs for df equals 5 and df equals 30 with the standard normal cutoff. The curves are centered together, so the practical question is how much extra tail distance the t distribution requires. At df equals 5, the 97.5 percentile is about 2.571, substantially larger than the normal value 1.96. The heavier t-tails demand a larger absolute statistic for the same two-sided alpha. At df equals 30, the corresponding t-value is about 2.042. The difference from 1.96 is smaller but not 0, and can matter when a statistic lies near the boundary. At df equals 100, the curves and common critical values are closer still. Using the exact t-value remains simple and preserves the model's intended uncertainty adjustment. The example shows that convergence is continuous rather than a sharp switch at df equals 30. A threshold such as 30 is a communication rule, not a theorem saying normal and t become identical. Use the actual df, an exact reference for final inference. Try it free at distryscope.com.